This is the circuit diagram. This is the DHT11 sensor and the Raspberry Pi. Already I told you DHT11 sensor has 3 pins. First one is the VCC, which is connected to 5 volt. The middle one is the data pin, which is connected to GPIO pin number 4. And the last one, the black one, is ground pin, which is connected to ground pin of Raspberry Pi. Now I will discuss different components of Raspberry Pi. This is Raspberry Pi 3B Plus. I'll open the case. This is Broadcom processor. This is Wi-Fi and Bluetooth module. There are 4 USB ports for connecting your keyboard, mouse. This is Ethernet port for connecting Ethernet cable to get the internet through Ethernet. This is audio port where you can connect your headphone and microphone or speaker. This is Pi camera slot where you can connect your Pi camera. This is HDMI port through which you can connect your LCD display or monitor or TV, whatever you want. Guys, I'll show you the SD card. This is the SD card. In this SD card, you have to install the Raspberry Pi OS. After installation, guys, you can see here, we can insert it into this SD card slot. That's it. This is micro USB type B port through which you can connect this wire, and now you can connect this wire to your laptop for getting power. This is LCD display slot. You can connect small LCD over here. But this is the port through which you can connect your LCD TV or monitor, all these things. But point to be noted, this is HDMI port. If you have VGA port in your monitor or TV, you have to use one adapter to convert VGA to HDMI. Then only you can connect to this port. There are 40 GPIO pins over here. Each of the pin having different functionalities. For example, ground pin, VCC pin, or you can say these are the pins, the GPIO pins, which can be connected to your device or the sensors according to your requirement. This is the blue one, is called the printed circuit board. So already I told you this is the type B cable. The one part is connected to this Raspberry Pi, another part is connected to the laptop or your computer, whatever you want. Now I'll assemble all these components for this project. This is Raspberry Pi. Already I have discussed about that. This is DHT11 sensor which has 3 pins. A positive, there is red one, will be connected to 5 volt of Raspberry Pi. The middle one, that is data pin, will be connected to GPIO pin number 4 of Raspberry Pi, and the negative, that is ground, will be connected to ground pin of Raspberry Pi. Now I will connect this sensor to this Raspberry Pi. First I will connect this pin, that is positive pin, to Raspberry. So connected. So now I'll connect the ground pin to this one. One. So now I'll connect the data pin to this GPIO pin number 4. Now I'll connect my micro USB type B to this Raspberry Pi and to my laptop. As you can see, the power is on. Now I'll search the Raspberry Pi IP. I'm clicking on Advanced IP Scanner. Click on Scan and search the IP of Raspberry Pi. Guys, you can see this is sky blue. That means it is active. 192.168.0.17. Copy IP. Cross it. Open remote desktop app. Copy it. Then connect. Click on yes. Give username as Pi and your password. So now I will tell you how to install DST11 library or Adafruit library. Guys, you can see the commands already I have discussed earlier. Now I will show you that how you can write program in Python for blockchain. Then I will show you that how you can secure IoT data. For my case, it is temperature and humidity data. This is the file folder. Guys, you can see. I'll open the file and explain the code first. As you can see the code. So first is the import date time for timestamp. Then import hashlib. In hashlib folder, we have sh256 function. I have used this function in this code. Then import OS, import time and the sys. So now I have written one input function for taking number of blocks to be inserted. Then the size of the block, that is AP input, size of the block, like if we give row and column, as you can see from the code. Then I have defined one function, that is input data, for taking data. So as you can see, this is the input function. After that, this function will return the data list to the calling function. After that, I have defined another function, that is the block input function. So here, as you can see, I am taking input from here and appending into the temp list. And then after that, I am appending this data from temp list to my list. And after that, this function will return the my list that contains all the data. This is the block, class block, which has block number is initialized to 0. Then the next pointer is null, initialized to null. Then hash also initialized to null. Actual list, this is also initialized to null. Nonce is the random number that is initialized to 0. Then the previous hash initialized to x0. Next is timestamp, which is initialized to datetime dot now, that means the current date time. So now we have init function, as you know, it's like a constructor in Python. So here we have the actual list and also taking input by this input function. So now I have printed all these values of Genesis block. This is the Genesis block. So guys, you can see I'm printing all these values like block number, the previous hash, the current hash, nodes, and all these things of the Genesis. So now we have the another function that is called diff hash, that will hash entire block except the next field. So guys, you can see this is the nonce, and then you have actual list, then you have previous hash, then you have a timestamp and the block number. So but I have not included the next field. We can also include the next field, doesn't matter with that. And then after that, this function will return this the digest of the entire block to the calling function. Then I printed all these values. As you can see, the block number, then previous hash, and hash, and all these things, date time, etc. That is now will come to the blockchain class. So that is the difficulty level is 20. So you can set to 0 also, then it will be easier for any user to give proof of work. Okay. So now the maximum nonce should be 2/32, and the target is given like this. So if we increase the difficulty level, then it will take more time to create block or mining the block. And if you set difficulty level low, then it is easy to mine the block. Okay, this is the block equal to Genesis block, and then there is a dummy equal to head equals to block. So that is the thing. So now this is the add function. How we can add the block. So that is the previous hash equal to the current block hash. Okay, so then you can increment the block number from here, and then block next equals to block. That is the linking part of the blockchain. Now come to the mining function. Here I've used one for loop phrase, and then if the block hash is less than equals to the target hash, then you can add the block, otherwise not, and you can also print the block. So guys, if a block creation, you print block created, and else this block is not created, that means you have to increment the nonce value, and then you have to add it to the block, and then rehash it and check with the target once again. And this is the calculation of start time, and then as you can see here, the how many blocks you want to create. This is the block mining. Okay, so here I have given b minus 1. Already I told you I have given input number of blocks to be created, so that's why the b minus 1, because the first block is Genesis block, that's why it is b minus 1. So you have to subtract 1 because we are not including Genesis block over here. Now we have a while loop where condition is blockchain head not equal to none. Then you have to clean the blockchain head, and this is the head equals to blockchain head. Next is the linking one, and this is the end time also. I have to calculate the elapsed time, and then I have to find out the average one divided by this. So this is the time difference multiplied by 1000 and divided by number of blocks. Okay, this is the block creation time. Okay. So you can say this is the computation time per block in millisecond. So now I'll execute the code. As you can see, you have to give the number of blocks you want to create. I'll give 4, and then I'll have to give the row size and the column size. So 2 by 2, and it will take 4 data values. I'm giving this 1, 2, 3, 4. Done. So guys, you can see the Genesis block. So the first block of the blockchain is called the Genesis block, and the block hash, block number, and the data what we have inserted just now 1, 2, 3, 4, and the timestamp also. You have to give inputs for block number 1, guys, over here. Similarly, you have to give inputs for block number 2 and block number 3. Guys, you can see from the output screen, hash of the block number 1 is matching with previous hash of the block number 2, and hash of the block number 2 is matching with previous hash of block number 3. Guys, you can see the computation time per block in millisecond. Now we'll explain the code by which you can secure the temperature and the humidity data. So first is import date time for timestamp, then import hash leaf for SH256 function, because we have used SH256 for hashing in this program. Then we have import OS, import time, and import sys, and import Adafruit DST for reading temperature and humidity by using DST11 sensor. Guys, you can see this is a function called defsen for taking input from the sensor. Humidity, hum and temp. This is the function Adafruit underscore DST dot read underscore retry. So you have to give the specification of the sensor, that is DST11 sensor, and the retapping number 4. It returns the humidity temperature value. So now we have another function called def log send, that is the input function. Guys, you can see there are 2 loops, and we are taking input over here and appending into the temp list, then we are appending into my list, then this function will return the my list. So now I'll come to block class. Here we have block number equals to 0, next pointer, that is none, and then hash is initialized to none, then the actual list, the actual data list I'm talking about, in this case temperature and the humidity list, that is also initialized to none. This is the nonce random number initialized to 0, previous has initialized to x0, then we have a timestamp and which is initialized to current time and date. So next we have the init function. As you know, it is constructor for Python. So code. So this is the init function. It will take actual list, and in this function we have printed the Genesis block values like block number, hash value, previous hash, timestamp, etc. etc. Then we have a hash function. So in this function we actually create the digest. So guys, you can see, so this is the nonce, then you have actual list, then you have previous hash, then you have timestamp and the block number. So we have created a hash of all these things. It is the block hash. We have not included the next pointer. Then this function will return the digest value. Then we have printed the entire content of the block, like block number, previous hash, current hash, and then timestamp, temperature, and humidity value and all. Okay. Then we have blockchain class. Here we have the difficulty level. Already I told you. Here difficulty level set to 10. You can set to 20 also or 0. If you increase the difficulty level, then computational time will increase, and if you decrease the difficulty level, then the computational time will be less. So here is the maximum value of nonce, and then you have the target value. So then block equals to block genesis, the genesis block creation. Then this is the add function for adding block, as you can see. Previous hash equal to the current hash. Then we increment the block number. This is the linking part of the block. Then you have a mining function where you have to check the current block hash and the target hash. If the current block hash is less than equal to the target hash, then you can add the block, and after adding the block, you can also print block created. So then if it is not accepted, that means the current hash is not less than equal to target hash, then just simply increment the nonce. But you can also add a random function over here to generate the random nonce. So here we calculate the start time, that is the block creation start time. So guys, you can see in the for loop, so I've given b minus 1 because we have seen that we have taken the number of block we want to create, that is the input as the variable is b, and then depending on that, number of block will be created. And also we have computed the block computational time, that is computational time per block. Okay, so I'll show you this one. Now I am run the code. Just wait. So just I'll give 4 and 2 by 2. Because I want to create 4 blocks for temperature and humidity value, and each block contains 4 values. That means 4 temperature value and 4 humidity values. Please wait. Previous one, the basic block creation, guys, you can see this is the genesis block created already. As you can see the temperature and the humidity over here. This is the block 1. As you can see, temperature and the humidity value. This is the third block, so we'll wait for another block. So over. So we have created 4 blocks. Each block contains, as you can see, each block contains set of temperatures and the set of humidities. In this case, it is 4. So guys, you can see, so just I'll check the previous hash equal to the current hash. This is the current hash of this block. This is the block number 2. Now it should be the previous hash of this one, guys. So guys, you can see these two are same. This one should be same as the current hash of the previous block. So guys, you can see, so this is the thing. So that is the way we can create blockchain. This particular blockchain is stored in the file, in this Raspberry Pi. So then you can add it. After that, if you want to create block, then you can add it with this blockchain. And there are 3 types of blockchains. One is for private, one is for the public, and one is the hybrid mode. This is the private blockchain, so we are storing to the Raspberry Pi only, guys. And if you create public, so it should be accessible to everyone, or if you can also create the hybrid mode also. So this is the private because we will store it into my Raspberry Pi. Now I'll change the difficulty level. So first I'll execute this code for difficulty level 0. First now I'll run the code. So it is, let's say it is 2 by 2. 2. Please wait. Please wait. This is the computational time. Remember 7394, this one. So when difficulty level is 0, that is the computational time. 7394.65 and dot dot dot. Okay, please remember this one. Now I'll increase the difficulty level in the code to 10 and execute once more. I'll give 2 and 2. So in this case, we have created 2 blocks and row size is 2 and the column size is 2. Please wait. Yes, please wait. This is the temperature and the humidity value. Guys, you can see this is the computational time per block. So previous was 7,000 something and this is the 11,000 something. That means if you increase the difficulty level, then your computational time per block will increase. So now I'll change it to 20 and check once more, run it once more, give 2, 2, 2. Please wait. Please remember the first one is 7,000. First one is a 7,000 something for difficulty level 0. Second one is 11,000 something for difficulty level 10. So now I have increased the difficulty level to 20. Let's check with that whether it is increasing or not. It is taking time because we have increased the difficulty level to 20. Okay guys, got it. So the computational time is 25,000, just almost more than double. Okay, and all the times are in millisecond. So that means if you increase the difficulty level, so then computation time per block will increase. That's it for today. Thank you very much.